Okay, so in this case, we use the Simpsons rule to calculate a double integral in the program C++. So in C++, we couldn't get an output of a variable, so then we decided to use the following method. Here's the double integral that we decided to do. We used a small sketch of it, which is this one, and the area that we're gonna find is this small region that we have chosen, or we have delimited with small rectangles. Then let's recall the Simpsons rule. The Simpsons rule says that the change in x over 3 multiplied by the function evaluated at different values is going to be an approximation of the integral that we want to calculate. So then for this first integral, delta x is going to be the upper bound minus the lower bound over the number of small pieces that we have decided previously, which is 10. Then it's the upper bound minus the lower bound over 10, which is gonna be the square root of x over 10. Then we're gonna use that delta x over 3 and multiply by our function evaluated at different points. As you can see, our function here is just 1. That means that we cannot evaluate it at different points because it's gonna be the same output. Then the only thing that matters is that we multiply this constant by the number 1, and then we add it together. Then we get as the answer that the first integral is going to be an approximation of the square root of x over 3 multiplied by 29. For the second integral, we're going to use something similar. This is going to be the second integral, and now we have a function over here. We first calculate delta x, which is going to be 9 minus 0 over 10, and that multiplied at the function evaluated at different points. We start at the lower bound, and then we have an increase of delta x until we get to the upper bound. And then that's going to be calculated in C++. And then here we completed the double integral by hand just to make sure that the result that we're going to get in C++ is going to be an approximation of the answer, which is 18.
Hello, now I'm going to explain the part of C++. As you can see, I include all of the libraries so we can do the math problems. I use the Namespace TD so we can use the functions count and cin. Okay, and once I did the interface and set all of the variables, let's go to the part that we're most interested. Calculate the dx, upper bound minus low bound, all divided by 10 because we're gonna have 10 iterations. Okay, now let's evaluate the points. As you can see in the last part, the first integral solved was square root of x, in this case it's low bound, over 30 times 29. So we evaluate each of the points as applying the Simpson rule, so we can have the outcome of the second integral. As you can see, assume all of the points as the Simpson rule indicated, and then result divided by 3 times the dx, low bound minus the up bound minus low bound over 10, and this way we got the result. So now we're gonna test our code about the double integral. Just a second. Okay, it's asking us for the upper bound. Put a 9 and lower bound to 0. As you can see, we got 17.5635. So it is very close, an approximation to the true result that is 18. Proving this way that it's possible to do a double integral in C++ even though we have a basic knowledge of coding. So, thank you so much.